Hello friends, welcome to Projectile Academy. In the last lecture, we have completed the discussion on the projectile motion. So in this particular lecture, we will start discussing questions on the projectile motion. Okay, so let's start our discussion. So what is given in the question is that if at any instant the velocity of the projectile is u and its direction of motion is at theta to the horizontal, then show that it will be moving at right angle to this direction after time u upon g cosec theta. Okay, so let us draw the projectile. So we have the projectile like this. Okay, so let us take a point A. Okay, so at this point A, the projectile is moving at a initial velocity of u and its inclination is at an angle of theta to the horizontal. Okay, so at passage of this time t, we have the direction of the projectile at 90 degree to the initial direction. Okay, so let us draw the perpendicular to the initial direction. Okay, so at this particular point we have velocity as v. Let us consider this. Okay, so this is obviously at right angle to the initial direction. Okay, so this angle is theta, so this angle will be 90 minus theta. Okay, so this velocity v is inclined at an angle of 90 minus theta to the horizontal direction. Okay, so since it is 90 minus theta, so this angle will be theta. Okay, so along the vertical direction we have v cos theta. Okay, and at point A we have the initial velocity along y direction is u sin theta. Okay, and along x direction we have u cos theta. Okay, so let us resolve the velocity along the horizontal direction. Okay, so along horizontal direction velocity is same. Okay, so we have u cos theta is equal to v cos of 90 minus theta. So we have u cos theta is equal to v sin theta. So v will be is equal to u cos theta upon sin theta. Let us take this as equation 1. Okay. Okay, so let us take this as equation 1. So now let us resolve the velocity along the horizontal direction. Okay, so we have this point as B and this point as P. Okay, this point as P, let us take this point as P and this point as B and this point as A. Okay, so along vertical direction of motion, okay, we have this as we have v is equal to u minus gt. Okay, along the vertical direction, so we have the final velocity as minus v cos theta because it is in negative y direction is equal to initial velocity along the y direction is u sin theta minus g into total time is t a p and b. Okay, so this path is a, p and b. The total time from a to b is t a p b. Okay, so we have let us put the value of v from here. Okay, so we have minus u cos theta upon sin theta into cos theta is equal to u sin theta minus gt. Okay, so let us take g in the LHS part. So gt is equal to u sin theta plus u cos square theta upon sin theta. Okay, so we have this as u common sin square theta plus cos square theta upon sin theta. Okay, so this is equal to u upon sin theta. This is equal to u cosec theta. Okay, this is g of t. So t is equal to u cosec theta upon g. Okay, so this is the time. Okay, so that it will be moving at right angle to this direction after time u upon g cosec theta. Okay, so this time taken in traversing a path a, p and b is given by u upon g cosec theta. Okay, At point B, the direction of the velocity is at 90 degree to the initial direction. Okay. So let us discuss question number 2. Okay, so let us discuss question number 2. Okay, so if v1 and v2 be the velocity at ends of the focal chord of a projectile path. Okay, so we have already discussed the tangents drawn at the ends of the focal chord meet at 90 degree. Okay, and u be the velocity at the vertex of the path, then show that 1 upon v1 square is plus 1 upon v2 square is equal to u square. Okay, so let us consider a projectile. Okay, so let us take 2 points. Okay, let us take a focal chord. Okay, so this AB is our focal chord. Okay, so this point S is our focus. Okay, so let us take this as V1 and V2 are the velocities at end of the V1 and V2 are the velocities at end of the focal chord. Okay, so our focal chord is A, S and B. So V1 and V2 are the velocity at end of the focal chord of the projectile path, and U be the velocity at vertex of the path. So U is the velocity at vertex. So this point P is our vertex. Okay, so let us take the initial direction of motion as theta. Okay, so we have the velocity along the horizontal direction as constant. So let us resolve the velocity along the horizontal direction at point A, P and B. Okay, so the horizontal velocity at point A, P and B are same. Okay, so the horizontal velocity at point A is v1 cos theta. Okay, and at point P we have the horizontal velocity as u. Okay, so velocity at vertex is obviously is the horizontal velocity, because at vertex we have no velocity along the y direction. Okay, so we have v1 cos theta is equal to u is equal to horizontal velocity along horizontal velocity at point B. Okay, so since we have A, S, B as the focal chords. Okay, so we have already studied that if we draw the tangents at the extremities of the focal chord, they will intersect at the right angle. Okay, so this will make a right angle. So this is 90 degree. Okay, this is 90 degree, this is theta, so this is 90 minus theta. So this is obvious, 90 minus theta, and this is theta. Okay, so this is equal to V2 cos of 90 minus theta. This is equal to V1 cos theta is equal to U is equal to V2 sin theta. Okay, so we have V1 is equal to U upon cos theta and V2 is equal to U upon sin theta. Okay, so what we have to find, 1 upon V1 square plus 1 upon V2 square. So we have 1 upon V1 square plus 1 upon V2 square is equal to cos square theta upon U plus sin square theta upon U. Okay, so 1 by U1, 1 by V1 square is equal to, this is square. Okay, so from here we have 1 upon, from here we have 1 upon V1 square is equal to cos square theta upon U square. Okay, from here we have 1 upon V2 square is equal to sin square theta upon U square. So this is equal to 1 upon U square. Okay, so 1 upon V1 square plus 1 upon V2 square is equal to 1 upon U square. So that we have to show in this question. Okay, so let us discuss question number 3. Okay. So the particle is projected with a velocity 2 root under GA. Show that it clears two walls of equal height A, which are at a distance of 2A from each other. Okay, show that the lattice rectum of the path is 2A. Okay, and the time of passing between the walls is 2 root under A upon G. Okay, so very simple question. So based on concepts. Okay, so what is given in the question is that a particle is projected with velocity 2 root under GA. Okay, the particle is projected at initial velocity 2 root under GA. Okay, such that it clears two walls of equal height A. So let us take this. We have two walls of height A. Okay, so this is of height A and this is of height A, and distance between the walls is of 2A. Okay, so distance between the wall is 2A. Okay, show that the lattice rectum of the path is 2A and that the time of passing between the walls is 2 root under AG. Okay, so let us find the directrix first. Okay, U is equal to 2 root under GA. Okay, initial velocity is. So we have directrix y is equal to u square upon 2g. So this is equal to u का वैल्यू क्या है 2 root under ga. तो this is 4 into ga upon 2g. So this is equal to 2a. So at a height of 2a we have the directrix. Okay, so our directrix is at a height of 2a from the x-axis. Okay, so this distance is a. So what will be this distance? So this distance will be a. Okay, so this whole distance is 2a and this length of this wall is a. So this distance will be a. Similarly here also we have this height of this wall is a and this whole distance is 2a. So balance distance will be of 2a. Sorry, this is of a because the whole distance is 2a. Okay, so let us identify the position of the focus. The focus is at a distance of a from the horizontal axis. So let us take this as focus. This point as focus. So what is the property of the parabola? The distance of the distance of a point on the parabola from the focus, okay, is equal to distance from the directrix. So this distance is equal to this distance. Okay, so distance of this point from the focus is equal to distance of this point from the directrix. Okay, so let us consider this point as P. So we have PA and this is B. So we have PA is equal to PB as per property of the parabola. Okay, so let us apply this concept here. Okay, so let us consider this. So we have the focus. Let us consider this point as S. Okay, so this point is focus. So distance of, now let us take these points as A and B. Okay, so distance of point S from A is equal to distance of this point A from the directrix. The distance of point A from the directrix is A. So this means the distance of this point from the focus is A. So this distance will be A. Okay, so this distance will be A as per property of parabola. Similarly, distance of this point B from the directrix is A. So by using the property of parabola, distance of this point B from the S will be also be A. This will also be A. So this means this total distance is 2A. Okay. So now what we have to find? The length of the lattice rectum. Okay, so this distance AB is equal to what is given in the question. Show that the lattice rectum of the path is 2A. Okay, so we have this as the lattice rectum is the chord that is perpendicular to the horizontal, perpendicular to the axis of the parabola. So this is axis of the parabola. So this is our chord. So length of AB is equal to 2A. Okay. What is latus rectum? Latus rectum is the focal chord that is perpendicular to the axis. So this chord is perpendicular to the axis. So this is our AB is our latus rectum, and AB is equal to 2A. Okay. Now what we have to show, the time of passing between the walls is 2 root under AG. Okay. So we have, let us consider this angle of inclination as alpha. So we have angle of inclination as alpha. So velocity along the horizontal direction is u cos alpha. Okay, so the horizontal velocity is u cos alpha. So let us consider the total time t is elapsed while this projectile is passing between the walls. Okay, so we have distance into the velocity along the horizontal direction is u cos alpha. The u cos alpha into capital T is equal to total distance. The total horizontal distance is 2a. Displacement is 2a. Okay, so the horizontal displacement is 2a. Okay, so let us find this value of u cos alpha. So we have latus rectum is equal to 2 upon g into u cos horizontal velocity का whole square is equal to latus rectum का value क्या है 2a. Okay, so this is our latus rectum. So we have 2a. So this gets cancelled. So we have u cos alpha is equal to ag का root under. Okay, so let us put here root under ag into capital T is equal to 2a. So from here we have t is equal to 2a upon root under ag. This is equal to 2 root under a upon g. So time is equal to 2 root under a upon g. Okay, so this is time of passing between the walls is 2 root under a upon g. Okay, so this is the solution of the last part of this question. Okay, so this concept we have applied. The distance of this point from the directrix is equal to distance of this point P from the focus. So here we have S as focus. So this distance we have found for using the value of the directrix. Okay, so length of this wall is height of this wall is a. So this whole distance is 2a based on the directrix. Okay, so this distance will be a. Okay, so since distance of B from the directrix is equal to distance of B from focus, so since this distance is a, so this will be equal to this distance. So SB will be equal to this distance. So SB is a. Similarly, AS is a. So say latus rectum is equal to AS plus SB. So this is equal to a plus a is equal to 2a. So latus rectum is 2a. Okay. Let us discuss further questions. Okay, so let us discuss question number 4. So what is given in the question is that a particle is projected under gravity with a velocity u in a direction making an angle alpha with the horizontal. Show that the amount of deviation d in the direction of motion of the particle is given by this particular expression. Okay, this is tan d is equal to gt cos alpha upon u minus gt sin alpha. Okay, so how we can solve this question? So let us draw the projectile. Okay, so the angle of inclination is given in the question as alpha. Okay, and it is projected under gravity with a velocity u. Okay, so with the passage of time, the velocity at every point is getting changed. Okay, so at every point the velocity is different. Okay, so this is v1. Let us consider this as v2. Let us consider this as v3, v4, v5. Okay, so at every point the velocity is getting changed. Okay, and also its inclination with the horizontal is also getting changed. Let us consider this as alpha 1, this as alpha 2, this as alpha 3. Okay, so with the passage of time, the velocity of the projectile at different points is different. Okay, and also its angle of inclination with the horizontal is also different. So we have v1 not equal to u, not equal to v1, not equal to v2, not equal to v3, not equal to v5. Okay, and also we have the angle of inclination with the horizontal is different of the projectile. Okay, so we have alpha not equal to alpha 1, not equal to alpha 2. Okay, so with the passage of time this velocity is getting changed and angle of inclination is also getting changed. Okay, so let us take one random point at time t. Okay, and calculate the deviation. Okay. Okay, so this is the path of the projectile. So let us consider a point A. Okay, so at time t, this projectile reaches this point P. Okay, let us take this point P. Okay, so the initial velocity is u and the velocity of the projectile at point P is v. Okay, so the angle of inclination is alpha initially. Okay, now after passage of time t, let us consider the angle of inclination as beta. Okay, so what will be the deviation? Deviation d is equal to alpha minus beta. Okay, so the initial angle of projection is alpha. After time t, the angle that the projectile is making with the horizontal is beta. So the deviation will be alpha minus beta. So what we have to find? Alpha minus beta. Okay, so alpha minus beta is this d. D is equal to alpha minus beta, that is deviation is given by this particular expression. Okay, so that we have to show. Okay, so let us show this. Okay, so we have this as the initial velocity is u. So let us resolve this along x and y axis. So this as u cos alpha along x axis, and along y axis this is u sin alpha. Okay, this is initial velocity in y direction. Okay, so now let us resolve this. So we have vx is equal to v cos beta and vy is equal to v sin beta. Okay, so this is vy. Okay, so the velocity after time t along y direction. This is velocity Vx. So Vx is constant throughout the motion. Okay, so the horizontal velocity is constant throughout the motion. Hence, this will be equal to u cos alpha. Okay, so we have the equation of motion as v is equal to final velocity is equal to initial velocity plus at. Okay, so let us write down this expression along the y direction. Okay, so let us take this as vy is equal to uy minus g of t. Okay, so the final velocity along y direction is this one, v sin beta. So v sin beta is equal to uy is u sin alpha minus g of t. Okay, so we have from here the tan of beta is equal to vy upon vx. Okay, so this is equal to vy. Okay, now vx is equal to this one, u cos alpha. Okay, so now let us write down tan beta. Tan beta is equal to vy upon vx. So this is equal to vy is u sin alpha minus gt upon u cos alpha. This is equal to tan beta. Okay, so tan beta is equal to, this gets cancelled, so tan alpha minus gt upon u cos alpha. Okay, so we have tan alpha minus tan beta is equal to gt upon u cos alpha. Now we have the deviation tan of d is equal to tan of alpha minus beta. This is equal to tan alpha minus tan beta upon 1 plus tan alpha tan beta. Okay, so this is equal to tan d. Okay, let us further simplify this. Okay, so we have tan of d. So deviation d is given by tan of d. So tan of d is equal to tan alpha minus tan beta is given by this particular expression. So this is gt upon u cos alpha upon 1 plus tan alpha into tan beta की value this one. This is tan alpha minus gt upon u cos alpha. Okay, let us simplify this. So we have gt upon u cos alpha upon 1 plus tan square alpha, okay, minus gt upon u cos alpha into sin alpha. This is tan alpha. Tan alpha into this expression. This is tan alpha. We can write sin alpha upon cos alpha. So this is equal to, this is 1 plus tan square alpha is sec square alpha. Sec square alpha is 1 by cos square alpha. So we have gt upon u cos alpha upon 1 upon cos square alpha minus gt sin alpha upon u cos square alpha. Okay, so let us take cos square alpha outside. So we have gt upon u cos alpha upon 1 upon cos square alpha into 1 minus gt upon gt sin alpha upon u. Okay, so let us further simplify this. So this cos alpha and this gets cancelled. Okay, so we have gt into this cos alpha will go into the numerator. So gt cos alpha upon u into u minus gt sin alpha upon u. This gets cancelled. So tan of d is equal to gt cos alpha upon u minus gt sin alpha. Okay, so we have this expression of expression for the deviation is given by tan of d is equal to gt cos alpha upon u minus gt sin alpha. Okay, so this is the expression for the deviation. Okay, so let us solve question number 5. Okay, so what is given in question number 5 is, okay, what is given in, particle is projected from O at an elevation alpha, and after time t second it appears to have an elevation beta as seen from the point of projection. Prove that the initial velocity was, let us take this as capital T. Okay, gt cos beta upon 2 sin alpha minus beta. Okay, so let us plot this first. So we have this particle is projected at an projected from O at an elevation alpha. Okay, so let us consider the initial velocity as u, and after t seconds it appears to have an elevation beta. Okay, so this elevation is beta. Okay, so this path, this complete path is after passage of time t. Okay, so this black marked part, this is, okay, so this path is after the passage of time t. Okay, so let us take this coordinate as h comma k. Okay, so this is p h comma k. So this is after passage of time capital T. Okay, so let us take a random coordinate at point q. Okay, so let us name this as x and y, the coordinate at x and y, and this this point q is with respect to the position of projectile at time t. Okay, so after time the projectile is time small t, the projectile is at point q, and after time capital T the projectile is at point p. Okay, so this point p is at an elevation beta as seen from the point of projection. Okay, so let us write down the coordinates of q. Okay, so we have the coordinate of q as x comma y, and this is after passage of time t. Okay, so how we can represent the x and y coordinate? So we have x is equal to velocity along x direction. So the velocity along x direction is constant, always constant. So u cos alpha. So we have u cos alpha into t x. And y, how we can represent? Y is equal to, we can write the displacement s is equal to ut plus half at square. Okay, so we can use, so this u we are writing in the vertical direction. So we have uy is, this is uy. Okay, so the initial direction, initial velocity along y direction. Okay, and this is gt minus of gt. Okay, So we have this as initial velocity u sine alpha. Okay, so we have u sine alpha into t minus half gt square. Okay, so this is coordinate coordinates of point q, which is the position of projectile after passage passage of time small t. Okay, so let us write down this one. Let us represent h and k in terms of this particular expression. Okay, so let us replace x and y with h and k and t with capital T. Okay, so let us represent this value of, let us write down the value of h and k. Okay, so we have p, h and k. This position is the position of the projectile after passage of time capital T. So we have this. So this coordinate is h and k. So this distance will be h and this height will be k. So we have tan beta is equal to k upon h. Okay, so we have tan of, let us write down the values first. So we have h is equal to, let us put x is equal to h and t is equal to capital T. Y is equal to k and t is equal to capital T. So we have h is equal to u cos alpha into capital T and k is equal to u sin alpha into capital T minus half g capital T square. So we have tan of beta as k upon h. So tan of beta is equal to k upon h. This is equal to u sin alpha into t minus half gt square upon u cos alpha into t. Okay, so this is equal to tan beta we can write as sin beta upon cos beta. Okay, this is equal to, t gets cancelled here, so you have u sin alpha minus half g of t upon u cos alpha. Okay, so we can do cross multiplication. So u sin beta, this is u cos alpha sin beta is equal to u sin alpha cos beta. Okay, minus gt upon 2 cos beta. Okay, so we have u of sin alpha cos beta minus cos alpha sin beta is equal to gt upon 2 cos beta. Okay, so this is u of, this we can write as sin of alpha minus beta is equal to gt upon 2 cos of beta. So from here u is equal to gt cos beta upon 2 sin alpha minus beta. Okay, so this is the expression for the initial velocity, gt cos beta upon 2 sin alpha minus beta. Okay, so this was asked in the question. Let us discuss question number 6. What is given in question number 6 is that a particle just clears a wall of height b at a distance a and strikes the ground at a distance c. Okay, from the point of projection. So what is given in the question is that this is our projectile. Okay, so it clears a wall of height b at a distance a. This is a wall of height b and this wall is at a distance a. Okay, so this distance is a. Okay, at a distance a and strikes the ground at a distance c. So it strikes the ground at this particular point. Okay, so this is at a distance of c. Okay, and this height of this wall is b. Okay, so this coordinate will be a comma b, and this coordinate will be c comma 0. Okay, and the initial velocity. Okay, so let us consider the initial velocity as v. This is capital V. Okay, so what we have to show is that the angle of projection we have to find, alpha we have to find, alpha is given by this particular expression, and the velocity of projection is given by this particular expression. Okay, so this particular question we can solve with the equation of trajectory. Okay, so let us write down the equation of trajectory. So we have y is equal to x tan alpha minus gx square upon 2v square cos square alpha. Okay, so we will apply this equation of trajectory at point A and B. So at point A we have value of x as A and value of y as B. Okay, at point B we have value of x as C and value of y as 0. So let us apply this at point, applying equation of trajectory at point A and B. Okay, let us apply this. So at point A we have the coordinate as a comma b, and at point B we have coordinate as c comma 0. If we apply the equation of trajectory at point A, we have b is equal to value of x is a, so a tan alpha minus g a square upon 2v square cos square alpha. Okay, and now at point B we have value of y is 0, so 0 is equal to c tan alpha minus gc square upon 2v square cos square alpha. Okay, so we have this as equation 1 and this as equation 2. Okay, so what we will do, we will apply multiply this equation 1 with c square and equation 2 with a square. Okay, so now let us do this. Okay, after multiplying we will subtract both the equations. Okay, so let us do the further simplification. Okay, so now we have this as after multiplication we have bc square is equal to ac square, this is a into c square, and this is a square c minus a square c into tan alpha. Okay, and we have ga square c square, this is c square a square, so this both will get cancelled. So this is the expression we are left with. Okay, so we have this as bc square is equal to ac c minus a into tan alpha. Okay, so this gets cancelled. So we have tan alpha is equal to bc upon a into c minus a. Okay, so we have alpha is equal to tan inverse bc upon a c minus a. Okay, so this is the angle of inclination that was being asked in the question. What is? Prove that the angle of projection is tan inverse bc upon a c minus a. Okay, so let us calculate the velocity of projection. Okay, how we can find the velocity of projection? So let us take this expression, that is c tan alpha minus gc square upon 2v square cos square alpha is equal to 0. So let us take this expression and do further simplification. So we have this as c tan alpha is equal to gc square upon 2v square cos square alpha. Okay, so we have this as c tan alpha is equal to gc square upon 2v square. 1 upon cos square alpha is sec square alpha, and sec square alpha is 1 plus tan square alpha. Okay, so we have 2v square upon g is equal to, this c gets cancelled, so this is gc into 1 plus tan square alpha upon tan alpha. Okay, so let us put the value of tan alpha from here. Okay, so we have 2v square upon g is equal to GC upon tan alpha. Sorry, GC into 1 plus tan square alpha is B square C square upon A square C minus A whole square upon tan alpha. Tan alpha is BC upon A C minus A. Okay, so this is equal to GC into A square C minus A whole square plus B square C square upon, this is A square C minus A whole square into A of C minus A upon BC. Okay, so this C gets cancelled and this A gets cancelled. This C minus A gets cancelled. So we have this as A and B will be left. This is this sorry, G we have already taken, no? So G will not come here. G we have already taken in the LHS portion. So G will not come here. So we have this as A square C minus A whole square plus B square C square upon AB C minus A. This is 2V square upon G. Okay. Okay, total 6 questions we have discussed. Okay, we will discuss further questions in the next particular lecture. Okay, thank you.